Hello, welcome back to another biometrics integration episode. Today, I am going to show you how to do biometric fingerprint authentication in CSharp using the ZKTeco Fingerprint API. First and foremost, this is how the console application that I will be showcasing to you will look like. Here you go. So it will have 10 steps, and in the scenario where a fingerprint match is found, this is how it will look like. In the scenario where there is no fingerprint match found, this is how it will look like. Let us now get started. The first thing that I'm going to do is to launch the Visual Studio IDE. So let me do that right now. So I'm clicking on the Visual Studio IDE. There it goes. It is initializing. And we are ready to start. So these are my other previous Visual Studio biometric integration projects that I've been doing in the past. But the one that I want us to dwell on today is this one. So I'm going to click on it. Yeah, and there it goes. So as you can see, we only have one class here, that is the program, and we have only one method, that is the main method here. And if I scroll to the bottom, you can see that the code is no more than 80 lines of code. So please stay tuned. Don't just leave. I'm going to take you briefly through this piece of code so that you see what happens. So from these screenshots that I took before, this screenshot here and this screenshot here, you can see that the application has only 10 steps. So I'm not going to bother you showing you anything else beyond those just 10 steps. So in the first step is where we do the ZKTeco API initialization. That will happen in step 1. Right here. Let me quickly take you to the documentation so that you can see how that happens. This is the ZKTeco Fingerprint SDK documentation. So I want to show you what is happening in initialization of the API. So right here in page 6. So the documentation says that this function is used to initialize the device. So once we call in it from our Visual Studio IDE, where is it? This one, I need to drag it here. So that is what we are doing in step 1. So we are calling this init function right here. Okay, I forgot to mention, before you run this application, you need to include this. You need to include the ZKTeco API in your Visual Studio IDE. And this is the driver. Let me take you to the driver. Let me show you the dependency. So this one is there. This is the DLL that you need to add into your C# project in Visual Studio. So that is the lib ZKFP C#. So once you have that, then you include it in your C# project this way. And once you have this in your project, you will be able to have access to ZKFP2. And from ZKFP2 class is where you can call the init function. Step 2. In step 2 is where we initialize the DB handle. So to initialize the DB handle, we need to call DB init function. So this is how we are doing it right here. Let me take you to the documentation so that you can see how the DB init function is defined. In the documentation, let's check out DB init. So here's DB init, that is in page 9. And you can see from the documentation that this function is used to create an algorithm cache. Alright, so this is the cache for saving the fingerprints that you are going to be doing comparison against, e.g. fingerprints that you have fetched from the database. Alright, So let me take you back to the code so that we check out step 3. In step 3 is where we add a registered biometric data from the database to the cache. Remember, that cache is the one that we initialized in step 2. So I've subdivided this step 3 into 2 parts, that is step 3A and step 3B. In step 3A is where I am going to get a fingerprint from the database, one that we will use for matching. In step 3B is where I'm going to add a fingerprint from the database that will not match. Alright, I will explain that later. For now, I have these two. I have step 3B commented out. But with that said, let me first take you to the database backend so that I show you how I ended up with this string here as the finger from database. So I open ID SQL database management tool. Then I access one of my ZKTeco databases. So this could even be your data from your time and attendance machine, a ZKTeco machine. So you see this ID here, that is ID 150. Then here where we have fingerprint data, that is finger 1. You see this one here? You see this one here? You see this one here? So I just copied one of these strings like this, and then I did copy, and then I pasted it inside here. I pasted it as a string for this case here, for finger from database, this one here, and for this one here. So as you can see, the ID of this fingerprint biometric data, the ID is 150. That could be anything else depending on what you have in your database. So remember this 150. I will later on show you where we are going to use it. Okay, in this small application of ours, we are not querying the biometric fingerprint data from the database. Because of the simplicity of the application, I just copied the biometric data, and I'm just going to use it directly, like the way you see I'm using it here in step 3A. So I have this variable here that I'm calling finger from database, and then I assigned it that value from the database. That is a fingerprint data. Okay, in 3A is where I have a finger from the database that I know will match, and in 3B is where I have a fingerprint image data from the database, one that I know will not match with the finger that I will compare it against with from the fingerprint scanner. All right. Now in step 4 is where we do the preparation of the finger from database. So now, depending on whether we are working on step 3A or whether we are working on step 3B, whatever it is that we are currently working on, whether it is in 3A or in 3B, we will need to convert that to blob. So as you can see right here, I am doing the 64 to blob of the finger from database. This one here or this one here. So for now, since this one is commented out, we are using this one. So we convert it to a blob, and then we save it as a byte array. That is finger from database bytes data, right? So this is a bytes array of the finger from database. In step 5 is where we add the finger from database to the registered cache. Now the registered cache is this one here. Is this one that we initialized here? Where is it? When we initialized the DB handle, we did that so that we can be able to add fingerprints to fingerprint image data to the registered cache. That is this one right here. I mean this one here. We do DB add, then we pass the handle here. The handle is the one that we got from step 2. after initializing the DB handle, and then we also pass the ID. Now this ID is the one that I want you to pay more attention to. So for my case, since I copied the finger from database, this string here, I copied it from this row here. I decided to use the same 150 that is here, so that I can know whether it is actually it. So as you can see here, I did int ID. I copied that fingerprint image data from this row here, that is the row with the ID 150, this one. Alright, then you can add as many fingerprint image data as you want by calling zkfp2.dbadd. But for this instance, because of the simplicity of this application, I'm just doing only one addition. I'm only adding only one entry into the registered cache. So for RC, I'm just calling it RC to imply registered fingerprints cache. So we have the DB handle, the ID. Remember I showed you the DB handle is from here in step 2, where we do zkfp2.dbinit function. And then the ID here, this one here, 150. Then the finger from database bytes data. Remember, this is the variable after we convert the long string here, the representation of the fingerprint image, to a byte array using this function here. Alright, so depending on how many number of fingerprints that you want to compare against the one from the fingerprint scanner, you will continue calling zkfp2.dbadd. Alright, but for me, I'm only passing one for now. But let's say you had 10, you will do zkfp.dbadd 10 times. Alright, then in step 6 is where we prepare the finger from the ZKTeco scanner. So similarly to the way I have gotten a string representation of a fingerprint image from the database, I also did the same for simulating a fingerprint image data from a fingerprint scanner. So that's why in step 6, we are doing something similar. We have the string representation of the fingerprint image from the scanner, and then we convert it to a byte array using this function here, that is base64 to glob. And then we assign that the outcome from this string conversion to base64 byte array, we assign it to this bytes data from the ZKTeco scanner variable here that we created. And as you can see, this is a byte array. Then in step 7 is where we do the actual identification. So for us to be able to do the identification, we will first need to have these two variables here, that is found ID. We initialize the found ID with a -1. You could put anything that you want, but make sure it is anything below a 0, that is. And then we have the score. We assign it a 0. So depending on whether there was a match found, if there was a match found, then this found ID will change to the ID of the particular fingerprint image data. Otherwise, if there was no match, it will be a 0. Same case applies for score. If there was no match, it will be a 0. Otherwise, if there was a match, it will assign a value that is greater than 0 to imply that there was a match and the score was this particular value that is greater than 0. So to do the identification, we call this function here, that is dbidentify. We do zkfp.dbidentify, then we pass the db handle from step 2, and then we pass the bytes data from the ZKTeco scanner, this one here, and then we pass the reference to the found ID, the one that I showed you here, we pre-initialized it with -1 and then the reference to the score. So this is the function that carries out the magic for fingerprint image data identification, or rather fingerprint image data authentication. If the outcome of calling the zkfp2.db identify results in a 0, if it is a 0, let me take you to the documentation so that you can see that one from the documentation. DB identify, right here, DB identify. So in this function here, this function is used to conduct the one.many comparison. Alright? And if it returns a 0, it means it succeeded. Right? Let me now minimize that so that I can take the code. So if it is a 0, we return this message here, message found. Then we also show the found ID value. And we also show the score value. Okay? Otherwise, if it returned another value that is not a 0, this code will not execute because it will mean that there was no match found. Now in step 8 is where I show you the found ID and the score, whether there was a match or there was no match. Let me show you in these screenshots here. This is how that is happening. So in step 8, if there was a found ID, it will return, like for this case is when now there was a match found and it returns the 150 and the score is 1000. But in the scenario where there was no match found, the found ID will be 0 and the score will be 0. But I will show you that practically when I run the application. Now in step 9 is where we free up the cache from the memory. So we call this dbFree. Let me take you to the documentation so that you can see the dbFree function. We are looking out for dbFree. So here it is. So in this function is used to release an algorithm cache. Alright. So from our code here, remember that time we did db init. This time we did db init in step 2. Right here. Similarly, in step 9, when we do dbFree, we are actually freeing up the registered fingerprints cache so that the fingerprints that were added to it are released from the memory. So to do that, we pass the db handle from the db init, the one we acquired after calling db init. This one here, the handle here that we acquired from calling db init. And then now the last bit, that is step 10, we call the terminate function from ZKFP2. Let me take you to the documentation so that you can see how that one is happening. ZKTeco API documentation. We are looking out now for terminate function. This is our terminate function. It must be, yeah, here it is. So in the terminate function, this function is used to release the library resources. That is the ZKTeco API library resources. And if you can remember, I mentioned that one from the very beginning, right here. Remember when I told you that you need to add this as a project reference. That is this DLL, this C# DLL, that is lib ZKFP C#. And how we are implementing it in our code by using lib ZKFP C#. So to free up that from our application, we do that in step 10, where we call the terminate function to release the ZKTeco API allocated resources that we initialize at the very beginning here in step 1, when we call the init function from the ZKFP2 class. Now that I've been able to take you through all the 10 steps. I want to practically show you what happens when there's a fingerprint match. So for when we have a fingerprint, when we want to test for a fingerprint match, I created these two separate scenarios here. That is step 3A and step 3B. In step 3A, I know I have this fingerprint image data that will match when compared with this fingerprint image from the scanner. That is where this one here, finger from ZKTeco scanner. Every other, for both 3A and 3B, I will compare the particular fingerprint string that we have for either 3A or 3B with the fingerprint image data string presumed to be from the scanner, that is finger from ZKTeco scanner. So now for now, I just want to show you how to do the comparison of finger from database, this one here. We compare it with the finger from ZKTeco scanner, this string here. Remember, we have already commented out 3B. For 3A, I already know that this finger will match with it is like saying comparing a saved left index image data in the database with a captured left index finger image data from the ZKTeco fingerprint scanner. Alright? And in scenario 3B is where I am comparing e.g. a right index finger image data from the database with a left index finger from ZKTeco finger scanner. You see now those ones won't match because there are two fingerprint image data from different fingers. Now let us run it, so what happens. Good. So you can see it went through all the steps, that is from step 1 to step 10. But then it's step 7 where it is being identified finger from ZKTeco finger scanner against the cache of registered fingers cache. You see that we receive match found and found ID is equals 150 and score is 1000. Alright. Then step 8 continues to show us the found ID and the score. Let me take you to step 7 again so that I can clarify some things. So in step 7, right here, but even before then, let me first take you to step 5. So I do ID as 150. And then I pass that ID inside the DB add. But I could even maybe set it maybe to like 200. Observe what happens. Set it maybe to like 100. That is like a unique way of identifying the particular finger from database that we are passing and its ID, so that if a match is found, we return that ID. This is because you could have several fingerprint image data that you are passing, like let's say 1,000. Then you want to identify the particular one that matched. So that's why you need this given ID here. So I'm going to run the application again with the ID as 200. So if it does a match again, it should return 200. Because that is the ID that we are passing for that finger, so that in case it is matched, we are given this ID. Okay, run it. Let me maximize it. Yeah, and you can see that when a match was found, it returned the found ID as 200, right? Score is 1000. Same case in step 8, the found ID is 200. Because we set the ID for the fingerprint image data that we are adding as 200. Initially, we passed it as 150. Okay, I hope up to that bit you have understood. But if you have any questions, please let me know in the comment section. So now I'm going to close this. And then I come back to the code. We go back to 3A. Where is 3A? So in 3A is where I'll show you what happens when we do a match against a fingerprint image from the database, the same fingerprint image from the database against the same fingerprint image from the scanner. So now let's comment out 3A. So commenting out 3A, then we uncomment 3B and comment out 3B. So in 3B is where I'm going to show you what happens when you compare two unrelated fingerprints, one from the database and the other one supposedly from the scanner. When comparing two different fingers, we don't expect to get a match because their fingerprint patterns don't match. So in that scenario, that is a no match scenario, we don't expect to find a match. So let us run this and see what happens. Remember, we still have our, where is it? We still set the ID as 200. So if there is a match, remember here where I wrote this, remember here where we have found ID. Where do we have found ID? Yeah, found ID here. So remember what I explained earlier. In found ID, we have first pre-initialized it with -1. Remember to always pre-initialize it with something that is less than 0. So if there is a match found, it will return the ID that was passed together with that fingerprint image data. Otherwise, if there was no match and you still passed your ID or whatever ID that you had, it will give you a 0. Anyway, let me just take you back to this so that I can explain this. The found ID again. So in found ID, match finger ID value, if match is found, you return the ID that was passed together with the fingerprint image data. Otherwise, it will return a 0. Let us run up the application now for the case of 3B. That is where we have two unrelated fingerprints. So we run the application. So what happens? Let me maximize this. So you don't see that green that we saw earlier because there was no match. So if found ID is 0, it means there was no match. So the found ID is 0 and the score is 0. So there was no match. So it couldn't return the 200 because that fingerprint image data that was passed together with its ID as 200 did not match the fingerprint supposedly from the scanner. And since it did not match, found ID, which was initially -1, became 0 because there was no match. So basically that's it. This is a very simple application that I built to demonstrate how ZKTeco fingerprint authentication works. In the next upcoming video, I will not be using pre-assigned fingerprint image data. I will be doing an actual fingerprint authentication, showing you how to capture the fingerprint image from the ZKTeco fingerprint scanner and populating the registered cache with fingerprint images from the database. So this bit here, instead of just giving it something like this, I will let the DB add be populated with fingerprint images data from MySQL. So this was just a simple application where I had to pre-initialize the variables that I was comparing with the already existing biometric data from the database and from fingerprint scan. So that's all for today. If you have any questions, please let me know in the comment section. If you'd like to reach out to me, my contacts are in the pinned comment as well as in the description of this video. See you in the next one.